Okay, so we've all seen this chart before, right? It's probably the most famous image in all of science, the periodic table. But what if I told you it's not just a list? What if it's actually a prophecy? Today, we're diving into how its creator, Dmitri Mendeleev, built a system that didn't just organize chemistry, but literally predicted its future.
I mean, just think about that for a second. How do you possibly know the properties of something, its density, its melting point, its entire personality, when no human has ever even seen it? It sounds completely impossible. But it's a question that gets right to the heart of what makes a scientific theory truly great.
And yeah, that's exactly what Mendeleev did. You have to appreciate the sheer confidence here. A brand new element, gallium, is discovered in France. Mendeleev, sitting hundreds of miles away in Russia, reads the report and basically writes back saying, "Hey, great discovery, but your data's wrong. You need to measure it again." And the craziest part, he was right.
And this right here, this is the proof. This is the moment his theory went from clever to legendary. Just look at these numbers. 4 years before gallium was found, he predicted its atomic weight would be about 68. The actual turned out to be 69.7. He said it would have a low melting point. Turns out gallium literally melts in your hand. But the real stunner, the thing that blew everyone's mind, was the density. The French chemist measured it as 4.7. Mendeleev, using only his table, insisted it had to be closer to 5.9. So they remeasured, and the actual density was 5.94. He corrected a physical measurement using nothing but pure logic. It's just incredible.
That single act turned his table from a neat organizational chart into something that felt like a message from the future.
So how on earth did he do it?
Well, to really get his genius, we need to go back in time and see the absolute mess he was trying to solve.
You know, in the mid-1800s, chemistry was just a total disaster. There were 63 known elements, but they were just a random list of facts. If you were a student, you just had to memorize hundreds of disconnected properties. There was no system, no map, just this chaotic sea of information.
Mendeleev's big breakthrough came from a surprisingly low-tech method. He wrote down the atomic weight and key properties of each element on its own card. And then he just started playing a game with them, a sort of chemical solitaire, shuffling them, arranging them, looking for any kind of pattern. And that's when he saw it.
He found the secret rulebook for matter, what we now call the periodic law. As he laid the cards out in order of increasing atomic weight, he realized their properties repeated themselves in a predictable rhythm. You'd get a reactive metal, then a less reactive one, then a nonmetal, and then the pattern would start all over again. It was periodic. This was the fundamental logic he'd been hunting for.
Okay, so finding the pattern was brilliant, but his true genius, the move that put him light years ahead of everyone else, was what he did when an element didn't fit the pattern.
And this really shows the critical difference in his thinking. See, other chemists saw the same data, but when a piece didn't fit their puzzle, they tried to jam it in anyway, assuming their system was wrong. Mendeleev did the exact opposite. He trusted his pattern more than he trusted the known elements. He bet that his periodic law was right and that nature just hadn't shown us all its cards yet.
So he left gaps in his table. He literally left empty spaces. And to him, these weren't mistakes or failures. They were placeholders. They were promises of elements that were still out there, just waiting to be discovered.
And he didn't just leave a blank space. He gave these future elements names. He used the Sanskrit prefix Eka, which means one, to describe where they should be. So the element that belonged one step down from aluminum, he called it Eka-Aluminium. It was his way of mapping the unknown. And he made some unbelievably specific predictions. He described Eka-Boron, Eka-Aluminum, and Eka-Silicon in detail, predicting their atomic weights and what they'd behave like. All science had to do was catch up and find them. But Mendeleev's confidence wasn't just about predicting new things. He also used the logic of his table to challenge and correct the accepted science of his own time. This is where he goes from being a great organizer to a true revolutionary. He believed in the logic of these chemical families so much that if an accepted scientific fact, like a measured atomic weight, contradicted his table, he assumed the fact was wrong, not the table. Take beryllium, for example. The accepted weight at the time put it in a group where it clearly didn't belong based on its properties. So Mendeleev just insisted the weight had to be 9, not 13.5, so it would fit with its chemical cousins, magnesium and calcium. And you know what? He was right. He did the same thing for indium. He was basically using his table as a fact checker for all of chemistry. And maybe the boldest move of all was the Iodine-Tellurium swap. If you just go by the numbers, tellurium has a higher atomic weight, so it should come after iodine. But Mendeleev knew that felt wrong. Chemically, iodine acted exactly like chlorine and bromine, the halogens, so he broke his own main rule. He swapped them, trusting their chemical behavior over the raw numbers. And decades later, when we discovered atomic numbers, it proved his gut instinct was spot on. What he ended up creating wasn't a finished product. It was a living system, one that was predictive, corrective, and designed to grow. The proof is in its flexibility. When a whole new family of elements, the noble gases, was discovered in the 1890s, did it break his system? Nope. They just added a new column, group 0, and the logic held perfectly. And today, that very same predictive logic is what guides scientists searching for brand new, super heavy elements in what they call the island of stability.
And this logic is not just for academics. It has a massive impact on our daily lives. Understanding the patterns Mendeleev first revealed is the foundation of trillion-dollar industries, from designing life-saving drugs to creating the silicon, germanium, and gallium-based semiconductors that power, well, pretty much everything in our modern world.
Now, for this incredible contribution, Mendeleev never actually won a Nobel Prize. But he received a much more lasting honor. Element 101 was named Mendelevium, literally writing his name into the fundamental architecture of matter that he helped reveal to the world.
And that really is the perfect way to put it. Mendeleev's table is so much more than a chart on a classroom wall. It's a powerful testament to seeing a deeper logic in the universe, of trusting a pattern even when pieces are missing, and having the courage to predict what lies just beyond what we know.